Hi, welcome to today's CAD lesson. In this exercise, we would be modeling this ball bearing. We would have 4 parts in all. Let's take a look at them. The first part is going to be the outer brace. We would also create the inner brace, the ball, the cage, and finally we would assemble and animate just like you saw in the beginning of this video. Do well to stick around to the end. Let's go ahead and start with today's exercise. We will create the individual parts and bring them together to assemble. So for the parts, we'll use a part template. Let's click on New App here, and then we would select the standard MMIPT because we want to work in millimeters under the parts create 2D and 3D object, and we would create. The first part is going to be the outer brace. We are going to use the revolve command for that. To revolve, let's first draw the 2D profile of the brace. So 2D sketch command up here, we want to work on the XY plane. Now under the rectangle tab, let's choose the 2-point rectangle and we can draw a rectangle here. We would dimension into the width of this, which is going to be the entire width of the outer brace is 62. We would enter that. Okay. And then the height of that, which is the thickness of the brace, is 24. All right, now let's apply a vertical constraint between the center of this baseline and the origin. And then also we would dimension the distance between this line right here and the origin as 106. Okay, now let's pick the circle command and we can draw a circle right here. The diameter of this circle is going to be 48. I'll enter that this time using the dynamic input box, which is going to be the diameter of the bulb, and we would enter. Let me apply a vertical relationship between the center of that circle and the origin. I would dimension the distance between the center of this circle and this line as 16. That fully constrains our sketch. And so let's go ahead and finish it. We would revolve. So the revolve command, the profile we want to revolve is going to be this one. And then for the axis we want to revolve around, let's use one of the default axes, which is going to be, let's see, X axis. The preview of that is exactly what we want, and so we can OK. Now let's finish this part off with some fillets. And so the fillet command, the fillet radius of 2 mm is fine. We would apply it to this edge, that one, and then also the opposite side. Let's OK that, and then change the appearance of that. So we would do the color font. Now I would save this part in a folder I had created already as the part number 1, outer brace. We will work on the second part. Now let's get a part template, a standard MMIPT, and create. Now we'll create a 2D sketch on the XY plane. Let's pick the rectangle command and draw a rectangular profile up here. We would dimension the width of this, which is going to be same as the outer brace, as 62. And then the height of that is also 24. We would dimension the distance between this baseline and the origin as 50. And then we would apply a horizontal constraint, a vertical one, sorry, between the center of this line and the origin. That fully constrains the rectangle. Now we will pick the circular command and let's draw a circle here. The diameter of that is 48, which is same as the diameter of the ball. We would apply a vertical constraint between the center of that circle and the origin. And then also we would dimension the distance between the top line of the rectangle and the center of that circle as 16, and enter. That fully constrains that sketch also. We would finish. Now we want to revolve. The profile we want to revolve is going to be this profile. For the axis also, let me select that. We are going to use one of the default axes, which is the x-axis. That is the preview. It is exactly what we want into. We would okay. Now let's apply some fillet of 2 to these edges, and then the opposite side as well. And okay. In other, so we see the rotation, I would place some holes here. So let's select this face and create a sketch. I would pick the circle command. Let me draw a circle here. The diameter of this, let's just do 10 and enter. We would apply a vertical relationship between the center of that circle and the origin. And then also we would dimension the distance between the center of that circle and this origin as 60. Now you can finish that, and then we would want to extrude. So the extrude command, we want to extrude cut, and the cut is going to be to a depth of, let's do about 3 mm, and we would okay. Now we want to create a circular pattern of this hole. So the circular pattern command, the feature is going to be this extrusion we just created, and then the rotational axis, we can choose any circular axis. The placement we want, let's do 6. The default is fine. Equally spaced around a 360-degree angle. We would okay. Now I'd want to mirror this on the opposite side as well. So let's choose the mirror command under the pattern group. The feature we want to mirror is going to be this extrusion as well as the pattern. So let's control and select that as well. The mirror plane, let's see, it is going to be the YC plane. Let's okay. The preview of that looks good. Now I will change the appearance of this also to horned and save this in that same folder as the part number 2, the inner brace. Let's get a new worksheet to create the ball. So we would create a 2D sketch on the XY plane. Now let's pick the circle command and start a circle at the origin. The diameter is 48. We would enter that. Now we would pick the line command. Let's draw a line to divide the circle into 2. Okay, we can finish this sketch and we want to revolve that. Let's revolve half of this. The axis of revolution, we would use this line and we would okay. Now that is all we have to do. Let's change the appearance of this. I'll do the black cast. Let's save now as the part number 3, ball. The fourth part is the cage. Let's get our worksheet. We'll pick the 2D sketch command and work on the XZ plane. Let's draw a circle from the origin. The first circle is going to be of diameter 172. We would enter that, and then we will draw another one of diameter 188. Now let's finish the sketch and we want to extrude. The profile is going to be this one. The thickness of this extrusion is going to be 32, and we would okay that. Now let's create the groove in which the balls will sit. So select this face and create a sketch. Now let's pick the line command and draw a line from this point here to that point. You can right click and then okay, but this line, let's make it constructional. And in order not for it to move, let me apply a vertical relationship between the center of that line and the origin. Now I'll pick the circle command. Let me draw a circle with that point of diameter of 48 and enter that. Now I will draw a line again to connect this point to this point. Now let's see. I think I'm able to move the line, so I would apply a vertical relationship between the center of that line and the origin. Now let's finish this, and we want to extrude. Sorry, we want to revolve. Let's select this profile, also that profile, and this one. The axis of revolution is going to be this line, but we want to cut that, and okay. Let's apply a fillet of radius 5 to this edge and that one, and we would okay. Now we would create a circular pattern of this feature together with the fillet we just created. For the rotational axis, let's go around this axis. The iterations, we want 8 of them around a 360-degree angle, equally spaced until we would okay. Now let's use the shell command to remove some unwanted material. So shell, the faces we want to remove will be this face, also this face, and then this face as well. We want to keep a thickness of 2 mm, and we would okay. All right, so that is it for this cage. Let's change the appearance also to horned, and I would save this as the part number 4, cage. Okay, we have all our 4 parts now. We'll go ahead and assemble. So let's open an assembly template. Under assembly, assemble 2D and 3D components, standard MMIAM, and we would create. Now let's place our first component. Let me look for that folder. The first component is going to be the outer brace. Let me open that, and then I would right click and place that grounded at origin. Let me press escape. I need just one. I would like to change the view and the visual style to shaded with edges. Now I can bring in the second part. And so let's go back to the assembly tab, and we would place. We'll bring in the inner brace. Let's open. We can drop that right here and press escape. Let me constrain these two. So constrain. The type is going to be a mate between this axis and that axis. There is an offset here, that is why we see this. I think it's from previous works I have done, so I'll just change that to 0 and uncheck this, and then I would apply. Now I would also apply a flash mate between this face and that face. It's going to be a flash and apply. Now let me close this and see what we are dealing with. Awesome. Now we can bring in the third part, and so place. It's going to be the ball. Let's open that. I will drop just one of it here. We would pattern the rest later. Now let's constrain. So we would open up the planes of the ball, and then also that of the outer brace. What we want to do is to constrain the YZ plane of the ball and the YZ plane of the outer brace. Let's apply that and close this for now. Let's see. Okay, now the next constraint. Let me collapse the work tree so we don't get confused. Now we are going to deal with the ball and the inner race. Let's open up their planes, and we want to constrain the XZ plane of the ball and the XZ plane of the inner race. Let's apply that, and then next we would apply, first of all, let's see. Okay, now let's apply another constraint, which is going to be a tangential one between the ball and this inner surface of the inner race. Let's do the solution inside and apply. We can close this now. Let's see. Awesome. Now we would pattern the ball. And so the pattern command up here under the pattern group, the component we want to pattern is going to be this ball. And then we want a circular pattern, so we select this option. And then for the placement, we can use this axis. And then we want to change the instances from 4 to 8. And the angle is going to be 360 divided by 8, which is going to be 45. So that way we see the preview of that. It looks good, and so okay. Now let's see. Next, let's bring in the last part, which is the cage, the part number 4. I would want to place that here. Let's now use the free rotate command to get this in a very good orientation so we don't find it difficult, constraining. I think this much is fine. You can right click and then OK. Let's see. All right. Now let's constrain. Let's see the axis that is going. Okay, this one is fine. And then we would constrain that with this axis. Let's apply that and close this. Now let me locate that. Okay, there it is here. Let's see. Awesome. Next, we would constrain for the outer race, the YZ plane. We want to constrain that with this face here. Let's flash that and apply. It's looking good now. Let's see. Okay, we just have to position it rightly so the balls fall inside that groove. For that, let's constrain. Let me collapse this. We are going to work now with the inner race. So let me open up its planes. Then that of the cage. We want to constrain. Let's see. The XZ plane of the cage with, let's see, for the inner brace, we are going to choose the XY plane. Let me apply that and close this. Now let's inspect and see. Okay, looks good so far. Now we would bring in another cage. So we would place, let's select that and open. Let me draw that here. We are going to do same as we did. So let me use the free rotate to get this in a good orientation. All right. Now we would constrain the axis here with the axis right here. Let's apply that and I would close this for now. Let me locate that and take it out. Okay. And next we want to constrain. Let's see this face here with one of those faces on the other cage. I would apply that. Let's close this and inspect what we have. Okay, we just have to put that in the right angle. So let me right click and collapse all. We are going to deal with the cage too. So let me open up its plane and then the inner race as well. So we want to constrain. Let's look for the axis. We can use the XZ axis of the inner race. And for the cage too, we would use also the XZ axis. Let's apply that and close. Let's inspect and see that has been neatly done and it is functioning correctly. Let me inspect that on the opposite side as well, and we will drive this and see that looks good. Okay, so we can also animate this and make it move on its own. We will do that. Let me collapse these. To do the animation, we need one more constraint. So we would open up the origins of the main assembly, that is the planes of the main assembly, and then also that of the inner race, and then constrain. We would do the XZ plane of the inner race and the XZ plane of the main assembly. Is this going to be an angular one? We want it to be a directed angle, and we would apply. Now let's close this and look for that angle we just put there, which is going to be this very one. So I would right click and drive that. For the start, it should be at the 0 degrees, that is fine. And then it should end at, let's do 360 times 10, which is going to be 3,600. Let me open this up for more options. We want it to start, end, and start as the repetition. We want to specify the increment with the amount of value, which is fine. We will change this to 2, and let's play and see what we have. Let's pause this or stop it, and we will change this to about 5, so we speed it up a little bit. Let me get the right view. Let's reverse the rotation. For the repetition, start, end, start, let's change that so we do that twice. Let's play finally. Okay, we can close this. Now that is going to be it for today's tutorial. I hope this has been helpful. If it has, please consider subscribing to my channel. Also do well to like this video. It helps the algorithm notice it and push it to a lot more people. If you have any comments, questions, concerns, or contributions, kindly leave them down in the comment section below, and I would address them as soon as I can. Don't forget to share this with your other card friends and save this as well. I'll see you soon with the next tutorial. Bye.